We have questions now. I'll ask a couple to start. So you mentioned the DAO, and you mentioned the DAO. So you talked about the potential of the DAO and a smart contract, which is a computer program running a computer program with no human intervention possible. Tell us about how the DAO ended, in your own words.
Yeah, so...
the end you told the beginning of the story, but you didn't tell the end of it.
That's because of the limited time I had. So yes, as was said earlier, well, some people said it was hacked, but it wasn't actually really hacked. So you can think of think of any legal contract. It's not so easy to pass. Lawyers make mistakes. You put that into code, and it was a mistake in the computer code. So somebody spotted a mistake, and they used that to siphon off the funds. All of the funds would have been siphoned off, but then the humans, who were somehow sitting above, decided they would stop that, and they did what they're not supposed to do. They intervened and then broke it. So yes, it didn't work.
So the problem with standalone computer programs running with no human interaction is that there's never been a computer program without bugs.
I don't know if I'd go that far, but then think about the real world, the rest of the world. So it's not the case that every single legal contract has not been broken. It's not the case that nobody has ever lost money by signing.
A human being.
It's actually the hobby of most attorneys to try to find a breach in the contract. Yeah. So if you think about people who are in computer science, I'm not going to use the word hackers, but it is. Researchers, exactly. They're going to try to find a way to use your code in ways that maybe you have not thought about. So that's what this person did. We still have debates about was it legal or not. This is why legal aspects on the blockchain are kind of complicated. Also, if you have a smart contract that runs in a malicious way, for example, who is responsible? Is it the 300 developers that used GitHub and committed their code? Who is responsible? You cannot go and sue them. So here with the DAO, one of the issue is that because of what happened, they had to roll back the blockchain, which is fundamentally against the idea of blockchain. And so then we had like a fork.
This was a big thing, actually.
Yeah.
The whole promise of Ethereum was that smart contracts would never change.
Yes.
They broke the smart contract guarantee, and a lot of people were very upset. They felt that it had broken the market integrity. This was hugely controversial, and Ethereum actually split into two.
Yeah, so you had Ethereum and Ethereum Classic. Yes. So people who didn't want... So, okay, this is actually pretty interesting because even if this is bad, it was actually a community decision. It's not like Microsoft decided to do an update and then pushed it into your computer. Here it was more like, okay, a mistake has been done, and it might potentially... have a very bad impact on Ethereum, the community, and the awareness we're trying to build. What should we do? And people say, okay, let's do a rollback and remove all the transaction. And people accept it, which means that they started running Ethereum, the new one. And people who didn't want to, they run Ethereum Classic. And because it was a majority of Ethereum nodes, this is how they won. But no central authority decided about it. So that's the good part.
They were also a little bit worried about the Securities and Exchange Commission, who then eventually said, yes, actually you did break the law, but we're not going to charge you. So take caution, because smart contracts don't actually supersede actual law.
But if it's of any comfort, the security engineer working on the DAO had a big depression during the summer after that and decided to implement kill switch. So now there is good practice that you can use for every smart contract, and people developing smart contract at the moment, they follow these guidelines. So
they do have human in control of them, but it turns out you actually probably want that. So I think we can take questions from the floor, actually. Let me see who is there. That fellow there. Do we have the microphone?
Hello, thank you very much for your speech today. It's been really enlightening for myself. I work in the energy storage sector, but on grid scale. And one of the things that I'm interested in is we are going towards a decentralized grid, but some projects in the energy industry, in engineering, require so much capital that it requires an institution or an individual to take huge amounts of risk. The way that I see with blockchain is it's all about distributing the decision and ultimately distributing the individual amounts of money. So how would you create a system where you need to take ultimately a big risk, whether that's in a big sum of money, to make something work, if you've got so many players in the individual system to then collectively make that decision? An example would be the idea that a lot of energy trading systems are going to a distributed network, but you still need large players in the center to provide stability when individuals drop out.
Can you speak to those?
I can try. So you can. It doesn't have to be all or nothing. You can think about a mixed approach with mixed players. So maybe some big players, some small players. It doesn't have to be one blockchain. You can have sets of blockchains, and then you can have a proportionality between the risk taken and the rewards given.
I'm working at the moment with a smart city project in France and probably in other countries in the world. And the idea is that you don't always have to do it on your own. You can leverage existing institution, existing expertise, and especially when it's about infrastructure, because you're not going to have access to this network. So what you're trying to do is build an ecosystem of actors, like the family I showed you. So people with diverse profile, diverse interests, but agrees on the fact that if they collaborate, they can create a new service that will be of added value to the user. And then if you do that, first you can have like a risk mitigation. You can also have a strict governance rule, and then you can use blockchain and smart contract to enforce them.
Okay. You have to watch the cases where you have some systems for energy distribution of tokens where you can't work out why they use the blockchain, and it's actually because they were looking for an excuse to sell ICO tokens. So it's one of those you have to watch, do you need a blockchain? So who is next? That fellow there.
And congratulations on the Kidna thing, which is very exciting. It strikes me, I know a little bit about blockchain, but I'm very much a novice. It strikes me this private key issue, which is a really big issue. I don't see that, I see that as being a real problem. And I want to know what you thought about that. Because if you've got something where you've got anything important, and usually it is something important, whether it's data or money, and if you lost some little key, you literally can't get hold of it again. I mean, I've got a few Bitcoin, not a few Bitcoin, a few Satoshi, whatever, and I've lost millions of things. I forget my passwords all the time, as I don't think I'm the only person who does that. And it seems crazy for all these, obviously this is a system created by some of the smartest people out there. And it seems a big fault in the system that if you lose your key, you lose everything. And that seems like I'm waiting for somebody to sort of solve that. And it seems like it does need to be solved.
You're right.
I don't know what you thought about that.
You're completely right. So everything that we have to learn from what happens with Bitcoin is that it was like the first version. What we needed to do is prove that it could work, which is why we have that proof of work that is completely not environmental friendly, why we have this private key issue that is completely not user-friendly. But we have people working on proxy contracts, which means that you can, for example, use a contract that manages your keys or the access, and that contract, you can actually put witnesses. So for example, if I lose my key, if other people claim that I'm the rightful owner of this money, if at least, for example, 3 persons sign this, then it unlocks the proxy contract and I can access again the funds. So it is that contract that actually owns the key because it will never be lost because it runs on the blockchain. And so we moved the issue to this circle of witnesses. It is not, but you can take a look at a multi-sig wallet. For example, you have some money with your friend or in a company, and you say we need 3 on 5 signature to unlock that money. And this is multi-sig.
What you see a lot in blockchain is in the cryptocurrency field, you've seen a lot where people go, we've got no intermediaries, but slowly the old intermediaries re-evolve because it turns out that they did things. Like you can't sue the blockchain, but you can certainly sue Coinbase, for example. It turns out that intermediaries do jobs sometimes. And so you have to work out, perhaps it's time for a shake-up, you'll probably end up with intermediaries again. Now, yes?
Is it working? Hello. Yes. I was just wondering about the sort of impending arrival of quantum computing, and
We knew this one was coming.
it's like QI, is it? I've got the big flashing symbol up behind me. Whether that is actually a kind of a threat because of the potential for solving those puzzles really fast at the beginning, and also securing the blockchain at the other end.
So if quantum computing comes and it solves all of these cryptographic problems and passwords, then the blockchain will be the least of your problems. So if you use a credit card of any sort, if you have anything locked away, anything in digital form, then it's gone. So
the idea is to use a quantum computer, and so it can calculate faster than any kind of computer. So basically, most of the crypto system we're using right now are going to be broken by this kind of computers. But one thing is, it's not at all for tomorrow. You can ask any computer, like quantum specialist, it is not for tomorrow. The second thing that is pretty interesting, I think, is people are building new crypto system for encryption with quantum computing, which means that we will have alternative by the time it happens. There is solutions today that are quantum safe. For example, everything that is ITS, so information theoretic secure, which means that even with the best supercomputer, even with a quantum computer, you can never break this because you don't have enough information. Just remember mathematics when we used to have those systems with several equations and several x, y, and z. If you don't have enough equation, you will never find them, even with the best computers. That's the same idea, and this exists already. So it will mostly be about us changing the way we build system and trusting the other researcher to come up with new solutions.
Right, that fellow there. Wait for the microphone. Speakers went very fast, so we have quite a lot of time for questions as it happens.
Thank you. In the Bitcoin blockchain, there's an incentive mechanism. The miners mine, and they get Bitcoins and transactions fees. What's the analogous incentive mechanism, or mining mechanism, or community in Kidna and other altruistic blockchains?
That's a very good question. So we didn't talk about this, but we have different kind of blockchain. The public blockchains and consortium blockchain. So public blockchain, like Bitcoin or Ethereum, anyone can join, and you don't have access to their identity. So you need to be very careful in your architecture to prevent malicious behavior, which is why we have proof of work that is like a very huge solution for a tiny problem. But actually, we need that because the risk and the the risk level is very high, the trust level is very low. So you need this to make sure that they're going to behave in an honest way. If you're using consortium blockchain, you know everybody on your network. You can do a consortium with insurer, you can do a consortium with banks, you can do a consortium with hospitals. That's what we are doing. So every hospital in our network is known, and if they behave badly, they're going to be not punished, but let's say kicked out from the network, just like you will do in a normal council. The reward for them is to actually save their patient life, which we believe is enough. And also because we do have a business model, you know that they get paid because they perform surgeries. And so what we believe is that if we have more transplants, they will organize more operation, and so we bring them basically more opportunity to earn this money. So it is a win-win for everyone. So there is a matching algorithm that is running amongst these hospitals. Each one push the data of their patients when they register a new donor-recipient pairs. In an encrypted way, it is pushed to everyone. And then there is a homomorphic or multi-party computation. We're still trying to find out which protocol fits best. That is going to perform a matching based on blood type, HLAs, things like that, like features that are already used in the systems, to see which pairs are actually a match. And then what is going to happen is that the doctors of the respective hospitals will get a notification just telling them, you need to call Dr. whatever, and you need to ask him about or her about this ID. And if you both do that, and he says, okay, I do have a match, and this is the idea I got, then you're going to be under the medical secrecy or privilege, and then now you can share all the data that you want. It is not Kindler's problem. You use whatever channel of communication people are already using at the moment, and you organize the logistics around the transference.
You're talking about a lot of this in the present tense, but actually it's mostly in the future, isn't it?
It is, yes. The only thing that we have running is the prototype, which is basically fake donor and recipients profiles, which with the real attributes, but it's not real person because we don't have the right to do so. And we are discussing with hospitals to run a pilot. So we can even do that with 3 hospitals just to prove what we have already proven mathematically, but we just need to prove it in the real world.
Yeah. When you have private blockchains like that, it's essentially just a shared distributed database between known organizations. So it's like you can use database to mean private blockchain in that sense. It's just a format of database in that sense. It's derived from the way the Bitcoin worked, but it doesn't have the same sort of public issues.
But it is not private to the point where it is a single actor. So be very careful. For example, if a company says we're going to use a blockchain, if they're using a blockchain just for themselves, then they can use a database. And sometimes we have to remind them.
There are many examples of this.
Each hospital's run nodes. Yes.
Hold on a second. Now, who else have we got? We're over on the right for the moment. So we have a fellow with the pinkish shirt there, I think. Or whatever colour it is, I can't tell in this light.
Hi there. So we touched on ICOs earlier on and the insecurity for investors on them. And blockchain seems to be sort of focusing on decentralizing everything. I'm just wondering, how do you see the governance of ICOs and sort of startups and the laws that come with that? How do you see that developing?
Wow, it's a big one.
I'm probably the one to actually answer that one.
Go on then.
The answer is that these are being treated increasingly as regulated financial instruments. The SEC in America, Securities Exchange Commission, they said a year ago, here are the rules, follow them. And in particularly the last couple of weeks, they've been coming bang, bang, bang down on a lot of people who've been misbehaving. Because fundamentally, these are offerings of securities, you know. They say, buy our thing, invest in it, and you'll get rich. That's the security offering. The rules are a bit different in Europe, but most of these things are, if they offer to American citizens, they're under American law, is the way it actually works. You're under every jurisdiction you touch. So what will happen is they're slowly turning into just stock offerings which are regulated by the regulators. This will happen with all cryptocurrencies. They're slowly turning into more normalized financial instruments. If you touch society, then society can touch you, basically. You could live in a separate environment, but nobody does. They're all part of the real economy. Does that make sense?
Yeah, that does make sense. It's as blockchain is such a global event, do you feel that we need a global blockchain governance, some kind?
I think if we achieve that without blockchain, like that would be a good thing.
I think in practice, in terms of financial regulation, fundamentally it's largely US driven because you'll know that all cryptos are priced in US dollars, no matter where you go. Everyone thinks in dollars. Even the greatest Bitcoin maximalists, you can't get them to stop talking about the price, you know.
Actually, it's also a matter of opportunities. Like, we all know that everything that has to do with laws is also a political tool. And in France, they understood that. And what our president says that France needs to be a place for entrepreneurship and things like that. And there was a movement saying blockchain nation. Very ambitious. But the idea was to say, we know that we don't want to miss the boat. So... So I'm learning too. So the idea is to say, if we can regulate in a friendly way so that startups stay in France and not go, for example, to Madagascar to do their ICO, I know people who have done that, then we can capture the value here in France and have French startups that are on the blockchain and maybe can be the big actors of tomorrow, which is something we completely miss with the internet revolution.
I think there will be a two-way. It's not... Yes, you know, technology touches society, so society can touch them, but I think it's a two-way dialogue.
It's always a continuous dialectic, working out how these things will work out, you know. Some people go too far in regulation, some just cut loose a lot of mum and dad investors lose all their money on Bitcoins, and the regulators get upset, and so it continues.
So I don't know if people have heard of Estonia. So there's e-Estonia.
I have my card.
Yeah, so anyone in the room, you could become an e-citizen of Estonia and trade there, and that's run, they claim, on a blockchain.
Yeah.
They claim.
The Estonia blockchain is an interesting one because that's a good example of blockchain as marketing.
Yeah.
It's literally not a blockchain.
It is not.
And they literally said, oh, well, when blockchain goes out of fashion, we'll rename it.
Right.
Because it's good software.
But at the same time, they've been the one working on this concept for the longest time. It is the most advanced digital society that we have. And at the last hackathon I did, it was at Berlin. 1,000 people at that hackathon. It was the biggest I've ever seen. People were able to use that card, the e-residency card, to actually connect to a wallet, for example, of Bitcoins. And that is also an answer to the question you asked, because now you can recover, like use your identity card to manage your funds. So things are happening in this way.
Okay. Now, there was another question over here. The fellow just behind you, actually. Pass the microphone back.
Hi, my question is Sajida. How do you deal with ethical dilemma, and how do you deal with in Kinder? How do you deal with ethical dilemma? For example, there is one donor and 10 people who need it. When the system grows, how do you decide who gets the one? And if you can see the identity of other users, can someone not bribe out of the system and just get the kidney or any other organ or any other thing?
Like, you said identity in the second part.
Yeah.
Yeah. So we don't know the identity of anyone in these files that we receive. Everything is encrypted, and even like the information to connect to the database of the local hospital is like a random number that we don't know. Only the doctors can do the mapping through their card, you know, the professional card with the chip on it, and so they can access this information. They are the only one that can actually connect back to the file of the patient. So that's one thing. And then the ethical dilemma, we don't actually have a big issue here because the algorithm for matching people have been running for years. I mean, UNOS is doing that. The Biomedicine Agency in France is doing that. We're basically just taking those rules that have been built, and people have put a lot of effort to write them. So we're just using it and building the matching algorithm in alignment with that. The only thing that we're changing is the way it is computed and the scale of the matching and this cross pair donation elements. So we don't have the right to prioritize anyone, and actually using blockchain, we can enforce that way better than now, because today we know that if someone has enough money or relationship, they can actually jump in the queue. And if you use a blockchain, it is not possible. Plus, if you have a doubt, you can still ask people to audit that blockchain. Anyone would be able to do it from the auditing institution and verify. So now you can enforce your rights.
Okay. Further questions?
Hi, thank you very much. I've heard say that the speed of adding transactions to the blockchain is not very fast, and I'm just wondering whether that is a problem for various different use cases, and that if there's any sign that there is computing architecture that can help the blockchain speed up.
So remember in my presentation, I talked about different consensus mechanisms. So one of the reasons why it's slow is that proof of work has to be hard. So one of the reasons why some people are thinking about moving to other consensus mechanisms, like proof of stake or proof of memory, is because they, in principle, could be faster. Also, if you have a permissioned blockchain, so it's controlled, then it can be very fast. But there are people working on different solutions to this.
And it is also a choice. Like most people, they don't know that, but if it takes 10 minutes to validate a block in Bitcoin, it's because it was designed that way. And it has to do with latency. So, like remember, we are in a network, it's decentralized, and peers are everywhere around the world. So there is some kind of delay. and we're using gossip protocols. So each node is propagating the information to the next node. So not everyone hears about the same block at the same time, which means that everywhere people are actually building blocks on some version of the blockchain, but they don't know if it's the canonical one. So at some point, it is okay because we converge. And by taking this 10 minutes, it's way easier because then we can converge and be sure that we are on the main blockchain. If it was more if it was faster, we will have like forks everywhere, and everybody will be mining, validating on a different blockchain. And it will
Ethereum, isn't it?
Yes. So we have then the problem of orphan blocks. Blocks that, for example, you're working on a block, actually, because of time and delay and latency, it is not, like, it is passed, it has passed. Another block was validated and you're actually behind. So you put it back, some transactions were not added, et cetera, et cetera. So now there is some kind of incentive mechanism for the nodes to actually include orphan blocks. So it is, yeah, complicated.
So do we think, though, that there's, are we missing out on use cases that we can apply blockchain to because it is slow by a sort of mainframe database sort of point of view, slower than servers?
You always have to think about scaling and whether things scale up. Like Bitcoin scaled to a certain extent. It was fast and free until about mid-2015 when suddenly it filled. And then suddenly everything was slow and clunky, and that was actually when Ethereum started rising. But Ethereum knows what happened to Bitcoin, and they're watching out for the same thing happening to them, and they're frantically working to come up with new computer science that will make that not happen to them. And it's an ongoing problem, yeah. Scaling is a problem.
Thank you.
Actually, Ethereum was almost killed by kitties. I don't know if you knew that.
Yes, Ethereum presently is unable to scale up to cat pictures, but they're working on it.
No, so the idea is that because of scaling issues and we have more and more dApps deploying on the Ethereum network, which is good, but the network didn't scale enough. So we're working on other techniques like state channel, so you can look it. It is about doing transaction in a peer-to-peer fashion, and you don't have to touch the blockchain. So for example, for a game, it is very interesting. We play a chess game, and only the result of the game is put in the blockchain, and a Merkle tree or some hash of every step of the game. But when we were exchanging, we didn't go to the blockchain to do that. So we can exchange information at the same rate as on the internet, and we don't have to wait for block validation to play that game. So there are alternatives.
Right, now.
Let's go one up here. Yep. Upstairs.
Someone up in the gallery.
Yes.
Can we get a microphone?
Yes, please. So I'm interested in understanding what caused blockchain to come to life. So what were the sort of external factors that resulted in blockchain coming to life?
One caricature of the answer is was the crash, the big crash that happened 2008. And
it
then
started work in 2007, though.
Okay, I said it's a caricature. So a caricature that there's the crash, and some computer scientists thought, well, why should we trust bankers to run the banking system? Us computer scientists can do a better job. That's not the full story, but that's part of it. So, and also if you think about the banking system, that's taking a notion of currency, which is hundreds and hundreds of years old, and started out with stones and sticks, and putting it on the internet, whereas this is an attempt to design currencies for the internet from scratch.
Yeah. The Bitcoin started from a very weird ideological pool of people called anarcho-capitalists who thought that they could have money with no government whatsoever, no banks, no regulators, no anything. This doesn't tend to work out too well in practice. Also, they wanted to go back to a gold standard, but they thought they could use Bitcoins instead of gold. And even actual gold standard type people don't take them very seriously. It was a very odd little ideological pool. And these people worked on this problem for about 20 years, and then one of them finally came up with, let's use this Merkle tree ledger, write it into a blockchain, we'll use this mechanism. And everyone went, oh my goodness, how did you get that to work? That's horrifying. But it sort of worked. They thought very early on, the power waste is going to be a problem. We better do something about that. And it's 9 years later, and it's an even bigger problem. So it's a good example of taking the very first paper and string mock-up of something and pressing it into service. This gives interesting results. So a lot of weird things about Bitcoin are because it came from weird people who wanted weird things. So this is where you get a lot of these stranger people who are Bitcoin advocates. Most Bitcoin advocates are just fine, but you will definitely hear about the weird ones if you open your mouth about the subject. Ethereum people are notably a lot more normal.
Thank you.
Is there anyone else up in the gallery? You've been neglected.
I don't think that actually Bitcoin people are that weird because
Like worse ones.
But we always
IOTA
have
people.
like trolls in the community. But just talking about the ideology and the crash you mentioned, it is just a story about people. You go to the banks, you want to access your saving, and the bank says, actually, no. And then you start thinking, is this my money or not? And this is pretty scary. And wanting to be able to access what is rightfully yours is not that weird. And developing a solution that enables you to own your own money and spending with whoever you want on the planet is actually makes sense for me. I don't know.
Ask a lot of the right questions.
So I would add that, often you do get paradigm shifts from people that are thought of as mad at the time. So I would give Einstein.
So they laughed at Galileo, but they also laughed at Bozo the Clown.
Yes, but sometimes the mad people are right. Sometimes.
Yeah, I had a quick one. It actually follows on from what you were just saying. With the proof of work, the analogy of proof of work saying it's using the whole power of Ireland to mine a couple of coins now. Is there any work being done to kind of come up with a concept that has a kind of environmental benefit rather than disbenefit, or a societal one in that proof of work concept?
The trouble is coming up with a calculation mechanism that's easy to check but hard to fake, and that's usually been the barrier.
So there are alternatives if you want to use a consensus solution. I think John mentioned quite some. Now, if I understand your question, you want to still use proof of work, but spend the energy for something useful. So there are projects doing just that, and it's in connection, I don't remember the name, with, when people are asked to donate resource power from their computer for research or things like that, or people are thinking we could use this computation for actual computation that needs time, and so then we help researchers. And also some of my friends, they just use it for heat.
So I've read there's a startup where you take part of a farm in your house and you use it to heat your house.
For real.
And then you get paid for that. So it's not in the blockchain space, but in the computing space. There are people thinking about these things.
Anyone else upstairs? No? Good. Any further questions from downstairs?
Hello, I have a question up here. Shall I carry on?
It's coming.
Upstairs in the gallery.
Thank you.
We have one
one downstairs.
You see, if we had a blockchain to do the question running, we wouldn't have this problem.
Blockchain everything. Can you use the mic? Because it's for the recording, actually.
This is the implication of GDPR on blockchain data.
I just wanted to hear your views on the implications of GDPR and having something on the blockchain that's there for effectively eternally.
So I can have a go at this. You want a small one?
Go for it.
So, So, of course, there's a lot of thought in the community about the relationship between GDPR and the blockchain. So for those that don't know, the new European law, which gives you all Europeans certain rights, including the right to be forgotten, the right to move your data, request data. And of course, if you have this permanent, immutable public ledger, then what's the relationship between that and the right to be forgotten? So I would say the answer is not clear. The real issue is that GDPR was designed as regulation to protect European citizens from the dangers of over-centralization. So it wasn't designed with the blockchain in mind. And you can think of the blockchain as an attempt from the technical community to overcome these over-centralization problems. So that's one thing. There's a mismatch between the regulation and technology, but that happens a lot. So there are different things one can do. So if you're really nervous as a company or as an individual user, you do not put private data on the blockchain. You put your private data somewhere else in your favorite place for storing private data, whether that is if that's in your pocket or on another server. And then what's unknown is, okay, what characterizations or summaries of that could you put on the blockchain for later?
Like the hash.
Like the hash. So some people think you can put the hash, I was mentioning earlier, the thumbprint on the blockchain. There's a discussion going on about whether that's really an encryption or not. I mean, technically, more or less, you can't go from the hash to the original file.
Except when you can.
Except when you can, yeah. So the answer is really pragmatic. So from the lawyers I speak to, which is not universal, you put some encryption of the private data on the blockchain, and if it's practically not possible in the current context to go from that summary hash or whatever what's on the blockchain to the private data, then you're okay. Yeah. But the key is, don't put your very personal data on the blockchain, but put some element of that you need for your public-facing persona.
And just to maybe add to the back end of that, if someone else places your data on, let's say, a decentralized version of YouTube, how are we preparing for that sort of scenario?
Well, if it's, for example, if you want to use a decentralized storage solution, you can use IPFS. So check it, it's a solution, and there's other. And so you can actually, yes, build a YouTube or a Facebook or whatever, any content platform using a decentralized network and using blockchain just to anchor the data. So anchoring means creating that link between the actual file and the proof of existence of that file. That can be the hash.
What do we do if someone did that to your data?
Yeah, exactly. So it can be the hash and the timestamp. So now let's say that you build this kind of platform. How can actually someone use this platform to put your data? So the idea is, if you can break that link, you can make it, it's not going to be deleted, but it's going to be not findable. I don't know how you can say that. You see what I mean? And it's to answer a question you didn't ask, but for example, if you, so that's the first part. The second part is you can also use an encryption mechanism and lose the key, or use a third key to make the data not readable. So these are all GDPR friendly solutions that we're finding to use blockchain at the same time being compliant with GDPR. And there's a company working on the degrees on blockchain, and they're using this 3-key solution so that if the user, for example me, I don't want my resume to be stored here again, I just break the third key and then the file is not readable. So you have to think out of the box.
Okay, it is coming up to 8:30. We have to finish up. So thank you for some fabulous questions. These were really good. So please give applause to
Sajida
and Tigo.